IoT-driven predictive maintenance and service management. So, by using the ITSM, we need to predict how to focus on the maintenance of the IoT devices. Okay, so we move from reactive to predictive. Okay, uh, instead of fixing the problem for equipment after it breaks down, we need to have we need to follow. It's better for us to follow the scheduled maintenance. Okay, and we should be able to optimize the field services by uh, the maintenance technician that have to precisely maintain the component of the service, and can even detect the early degradation signs. Okay, and we also able to manage our spare parts accordingly based on a real-time assets management, and we can contact our vendor to give a spare part supply chain system automatically, and quantifiable return of investment, uh, because by using the predictive maintenance we able to optimize our costs on maintenance. Okay, security challenge in IoT environments. We need to make sure our IoT devices secured from a massive attack surface. Okay, because we have lots of thousands and millions of IoT devices under our civilians, so we need to uh, protect from any exploits or breaches to our network. And a weak default credential, so you need to have your IoT device secured in terms of using a username and password, and lack of built-in encryption. This is one of the another challenge. You need to have a budget conscious manufacturers that often omit the encryption standards for our IoT device, and insecure update mechanism because of lacking of robust firmware updates pipeline. There are many deployed IoT device remain permanently vulnerable to any attack or any software flaws. Okay, IoT governance, compliance, and privacy. So this is more on regulation, rules and regulation. You know that when you are governing your IoT devices all over your network, you need to make sure that you always comply with the privacies and rules. Okay, one of the example of data privacy rules is the GDPR. The In Malaysia we have the PDPR, the Personal Data Protection Act, and you need to make sure your data is stored and safely, and you need to have a device lifecycle governance. Once the IoT device exceed its lifetime, you need to make sure it be decomposed safely. Okay, edge computing and IoT data processing. Okay, so edge computing is the newly technology, a modern technology. By using edge computing, your IoT device able to decentralize its intelligence, meaning that you can push your device to move into a smart devices. Okay, that can able to work by its own without your intervention, without a human intervention. Okay, and edge computing also can reduce your latency, your bandwidth latency, because all the data has been processed in the device itself at the edge of the network, and it have a real-time responsiveness. Okay, and the bandwidth preservation, you can reduce your network burden or bandwidth by using the edge computing. Okay, and offline resilience meaning your IoT device able to work by its own, able to work without the network availability. Okay, even though it is offline, your IoT device still able to process the data. Okay, and the IoT identity and access management. So this is the way on how to access your device or IoT. Okay, so first of all, you need to have a unique device identity. Each and every single of IoT device need to have its own cryptographically secure unique identity. Okay, and you need to have a zero trust architecture philosophy. This is the principle that to ensure that your IoT devices is trusted. Okay, and also have a continuous requirement of verification, and it also have a certificate based authentication. It has its own digital certificate. It has its own password, and so we want to prevent anyone from breaking into the device and able to break into our network. Okay, and we have the granular access control, the RBAC policies. This is the access control management. We want to make sure that all the devices able to authorize the application endpoint and the specific database scheme. Okay, next up, the network management and bandwidth optimization of IoT. Okay, so when we are using the IoT device, we need to manage the bandwidth network burden. Okay, because we have a high density traffic management. In order to make sure our devices able to send data over the internet, we need to make sure we're able to handle thousands of simultaneous intermittent data, okay, that flowing over the net. And we need to have activate the QoS prioritization. You need to able to your ITSM should be able to optimize based on the priority. Okay, and the device dynamic network slicing. Use the 5G network slicing. You must isolate your IoT device bandwidth through a channel, a visual channel and tunnel, to avoid any latency from sharing network bandwidth with other resources. And a proactive link monitoring, automated network tools monitor with signal degradation and congestion, and also able to detect any packet loss during the data transformation. IoT assets configuration management. Okay, so when we are managing our IoT assets and configuration, we need to have automated discovery tools. This is very helpful for you, especially when you are working with a large scale enterprise organization. And also your firmware of your IoT device must have the ability to track the configuration. Okay, and this will help you to manage the firmware easily. Okay, and then we have a physical and logical mapping. You need to know where is the location of your physical IoT device being installed. Okay, so you need to know the physical location, and by knowing the physical location, easy for you to do the proactive maintenance. Okay, and you have a dynamic assets lifecycle control, meaning that you can track, you have the inventory to track, have the record of your device lifetime, expiration dates, for example, and you can ensure optimal finance management for the IoT investment. Okay, incident and problem management in IoT ecosystem. So we know that all of the IoT device or any device basically have its own issues or problem, or have a failure, for example. So when the failure happen, the downtime happen, the device itself able to give you an alert, okay, able to trigger you to raise an incident ticket to your ITSM, so that you know that the device is failed and need to be maintained, or need to be bring back up again, okay. And you need to have a root cause analysis, why it happened, how we can prevent it from happening, and what is the preventive measures, okay. And also you should be able to have the automated self-healing scripts, okay. For example, like when it's time for the device to be reboot or restart, it should be able to reboot or restart by its own, okay. So you have a scheduled maintenance, a scheduled reboot accordingly, so without any human intervention, okay. And you have a disaster recovery playbooks if something happened to the device, maybe a grid failure or outages, power outage, should have a backup plan, okay. Data management, analytics, and storage for IoT. So because of the IoT generates a vast volume of data daily, your ITSM should be able to handle a big data volume, okay. And this data is stored safely, and it require a data cleansing and normalization, because the raw data is noisy and not standardized, okay. So you need to, your ITSM need to able to handle and clean the data before it can be analyzed and synthesized, okay. And then it should have a time series database. This is to make sure that the data that's stored in the database can be stored, can be indexed, and it will save you time to retrieve the data back when you need the data, okay. And the machine learning integration, you can use AI and machine learning and use the learning algorithm to process the data, and you can discover hidden pattern or meaningful data insights from the data, the raw data, okay. Part 15, the environmental and physical challenge in IoT operation. So when you are dealing with IoT devices, you have a challenge in terms of weather and element resistant, okay. Because most of the IoT device installed outdoor, okay, it's open for extreme temperature, too hot or too cold, too moist or maybe too humid, and a dusty environment, and corrosive, especially if you install the device near a river, a water-based resource, or near a beach, okay. And also you have a challenge in supplying a power or electrical power to your device, especially if you are placing the device in a extreme location. And we want to avoid a physical tampering and vandalism, okay. So we don't want our device to be accessed by intruders, okay, to vandalize the device. And the logistic deployment hurdle, installing, calibrating, and maintaining, your technical team or your on-site engineer, they need to access to the location of your installed device. So we need to handle this type of challenge, the access challenge, okay. The business value and innovation through the IoT device, okay. When you are using the IoT device, it should bring value to the business or the organization or the company, okay. So when they are using the IoT device services, it should be able to return revenue stream into the company. It should be able to enhance the company, the customer experience, okay. So for example, like the smart product can bring a certification for the customer, okay. And it should able to improve the operational visibility, okay, and sustainability tracking. Your IoT device should be able to improve the environmental friendly, the green technology, or the carbon emissions, okay, prevention to improve your business organization sustainability targets. Okay, next we have the vendor management and ecosystem governance for IoT. The third party risk assessment. So your vendor should be able to maintain the risk, manage the risk that bring from the vendor of the software they are providing to you. Okay, vendor lock-in risk. This is the protocols that able to control the ecosystem of your IoT devices that's supplied by your vendor, and it must comply with the SLA environmental of IoT devices, the service level agreement between you and your vendor. Okay, so anything happen with your IoT device, it should be handled accordingly with the agreement with your vendor. Okay, if they need to replace the hardware within the warranty time, so it need to be replaced. And also interoperability standards. Your IoT device should be able to operate with a different standards of environment with another manufacturer or another platform. Okay. Testing, quality assurance, and deployment of IoT. Simulated environment testing. So before you use the IoT device, you should test it first. Okay, so we have a phases of rolling out strategy, phase by phase deployment before it goes live. Okay, and then over the air, OTA update testing. You need to test whether the IoT device have able to update the firmware automatically with a special mechanism. And rigorous scalability testing. This is a vast testing platform. You need to simulate the actual situation, okay, with a different platform on using the IoT device. Next, we have the future convergence of IoT with artificial intelligence and ITSM, the AIoT. Okay, so AIoT is the combination of artificial intelligence with IoT device. This will improve autonomous, automatic intelligence decision supports and have a cognitive service desk. Okay, this is the ITSM platform with AI that able to resolve a user's issues with seconds. Okay, autonomous operation, meaning that the IoT device with the help of AI able to self-heal if the IoT device have a failure. And advanced predictive analytics, it able to predict the hardware failure and also can help you in decision making, okay, for business market analysis and prediction. Okay, so this is the last slides of topic number 3, which is the summary and key takeaways. Number 1, when you're using the IoT device with ITSM, you should be expand your IT boundaries. Okay, and from the physical support to a sensor driven environment with a real-time monitoring and specialized management. All of this should be covered by the ITSM. Okay, and architectural complexity. Okay, so the IoT device should be integrate with a multi-layer architecture, different platform, different operating system, a different manufacturer. Okay, and some of the critical challenge in managing the IoT that require a massive security vulnerabilities. We need to make sure all the IT devices been secured with protection algorithm, username and password, and have a harsh physical operating environment should be settled. And the last important key is the strategic transformation. So when you are using or managing the IoT device, it should be act as one of the powerful catalysts of predictive maintenance. You should be able to make sure that the IoT device operate accordingly and performing well, and this will improve your business service innovation. Okay, so that's the end of our topic number 3. We will continue later on with topic number 4. Thank you.